Any doubts, please put it in the chat box. Okay, then we will move to the next problem. It's called as assignment problem. So it is simply called as assignment problem or a job assignment problem or subject assignment problem, everything. Okay, so in general it is called as assignment problem. Okay, using branch and bound algorithms. So in general, if you go for the assignment problem, you're having 4 different solutions. One is you can apply brute force approach. That is nothing but the classical approach you can apply. Okay, next one is Hungarian algorithm. So Hungarian algorithm you can apply. So that is in the Hungarian algorithm, similar to the TSP problem. Here you have to allocate both row-wise reduction as well as column-wise reduction, and you have to proceed. Okay, and next one is by using a graph-like structure, that is DFS or BFS on the state space T, you can able to find out the solution. Okay, and fourth solution is finding optimal solution using branch and bound. So this is present in our syllabus. So we are not discussing about the first 3 solutions like brute force approach or DFS BFS approach or one more approach. What is that? Hungarian algorithm. We are not discussing the first 3 solutions, whereas we are interested only in the 4th solution alone. Okay. Okay. You just go through this point. I will straight away go to the topic. So in the 4th one, using branch and bound also, we are having 2 different approaches. One is for each worker or for each person, you have to select a job with the minimum cost from the list of unassigned jobs. From the list of unassigned jobs. I will explain you later. Okay. So that is you have to take minimum entry from each and every row. This is the first approach. If you're going with the second approach, for each and every job we are going to consider. For each and every job, see, so the first approach is nothing but according to the work you are going to allocate the person. So this is a table. In the table you have contains job and person. You are having person informations and you are having job informations. We go with the first approach. For each and every person you are going to allocate the job. If you go with the second options, just to reverse, for each and every job you are going to find out the optimal, you have to find out the concerned or correct persons. Okay. So the first one is by using a row wise selection. Second, if you go with the second approach, you can able to move from the column wise approach. But here again we are going to use the first approach. Okay. So see the problem. I think the image is blurred. I will scan and I will upload it again. Okay. So the assignment problem here, assignment problem we are going to solve by using branch and bound concepts. As I said earlier, it can be solved using different methods, either Hungarian method, brute force approach, or DFS and BFS approach. And the fourth option is branch and bound. In the branch and bound also, either you can proceed row wise or column wise. Either of the approach you can follow. But here we are going to discuss about row wise approach. Is it clear? If you are interested, you can try it for the column wise approach also. So here we are going to assign each person one task. Okay, there is only one job is allocated to each person. That is our objective. That is called as assignment problem. If I'm having 10 problem means the 10 problem will be assigned to 10 persons. Or you can say that in the reverse manner. Okay, so each person is having individual assignment. Each person is having one assignment. That too unique assignment. Is it clear? You can say in both the ways, and your objective is to minimize the cost. So branch and bound means always you are talking about the minimization problem. So your objective is to minimize the cost. Okay. So this is very simple problem. You can solve it very easily. So let us assume that the job is present in the column and person is present in the row wise. Is it clear? So these are the person's informations. A person or first person, second person, third person, fourth person. So these are different jobs. Job 1, job 2, job 3, job 4. Okay. So from this table, we are going to find out which job can be allocated for which person. Which job can be allocated for which person. At the same time, the cost should be minimized. Okay. So for this, first you have to consider the lower bound calculation. For this, you have to select the minimal element from each and every rows. If you select the first row, the minimal element is 2. If you select the second one, the minimum element is 3. Here it is 1, here it is 2. So the lower bound for this table is 8. Okay. So this is used in the next graph. Okay, so my lower bound is equal to 8, isn't it? My lower bound is equal to 8. And you are going to select the first person. You are going to select the first person. Okay, how many jobs you have? 4 jobs. So you have 4 branches. You are having 4 branches. So here I am going to find out, okay, which the first person will take which job, either job 1 or job 2 or job 3 or job 4. I am going to decide it. Okay. So for this you have 4 branches. Since we are having 4 different jobs are available. So first person, A means first person can select job 1 or job 2 or job 3 or job 4. 1, 2, 3, 4 represents different jobs. Okay. And then now we are going to find out the cost value for each individual branches. How will you find out the cost? Okay, A1. So just you go to copy the A1 value. Well, this is A1. So this is A1. It is not clear. This is A1 value. Okay. So A1 value plus least value from the remaining columns. You have to select the least value from the remaining columns excluding first row. I will tell you later. I will tell you now. How we are going to find out A1 means, okay? How we are going to find out A1 means, just strike out the first row. This is for the second level of the tree. You have to, for the second level of the tree, you have to strike out the first row. Okay, just to copy the A1 value. What is A1 value? 9, isn't it? So A1 value is equal to 9. So for the remaining column, you have to exclude. This first row is getting excluded. So only this 3 cross 3 matrix. See, only this only this 3 cross 3 matrix will be considered. Okay, already you have excluded the first row, but you go to copy the A1 cell value. There is 9. You can copy A1 cell value 9 plus. So from the second column, you go to select the minimal element 4. You should not select 2. See, you should not select 2 from the second column since 2 is already in striked out pot. You should not select the element from the striked out pot. Okay, and go to the third column, select the minimal element 1, isn't it? Go to the fourth column, select the minimal element. This is actually 8. It is not 3, it is 8. So it's 4. So 9 plus 4 plus 1 plus 4. So 13, 14, 18. And similarly, how will you find out if A is equal to 2? If A is equal to 2 is your second branch, right? So A is equal to 2 means you have to select A2 value. So A2 value is 2. How will you find out A2? First row, second column value. A2 is equal to 2. Okay. So for the first column, select the minimal value. So the minimal value is equal to 5. Isn't it? So there is no need to select the second column. Already the value is filled. Go to the third column. The minimal value is 1. Go to the fourth column. The minimal value is equal to 4. So find out the answer. So 7, 8, 12. Is it clear? Here, so this is A1 is equal to value. So this is A is equal to 2 means you have to go to copy the A2 value. Then remaining value is extracted from remaining columns, as well as you have to exclude the first row. You are going to select the minimum value such a way that the first row should be excluded. Okay. So now you have 4 different values, isn't it? So 18, 12, 20 and 18. Your objective is to minimize the cost. So this will act as a root node for the third level. Okay. So the meaning is first person takes job 2. First person takes job 2. Okay, this is the meaning. So from this one, you are going to select the from A2. So the first person job is decided, isn't it? So the remaining jobs available is 1, 3 and 4. See, now the job 2 is locked. It is assigned to the first user. So this will be act as a root node for the third level, whereas here you are going to select b is equal to 1, 3 and 4. Since second job is already allocated, isn't it? So b is equal to 1, b is equal to 3, b is equal to 4. So for this second row is getting excluded. Okay. So that the meaning is that you are going to strike out the second row, and again you are going to compute these values. So this b1, this is b1 is nothing but 6. b1 value is nothing but 6 plus. So this is a minimal element from the second column. This is minimal element from the third column. This is a minimal element from the fourth column. So you have to select the values and compute in the similar manner. Again, you are going to compare these three. Now, this is not the answer. This only will be the answer. So again, if you compare, okay, so 13 will be least cost. So B is equal to 1 will be assigned. So the meaning is that first job will be allocated to second person. Second job will be allocated to the first person. So the remaining left out is 3 and 4 only, isn't it? So C is equal to 3 and C is equal to 4. Again, repeat the same steps and find out the cost. Okay, so this is the least cost. Okay, so here there is no need to consider the lower bound value, isn't it? So here there is no need to consider the lower bound value, since if you know first job will be allocated to B, second job will be allocated to A, third job will be allocated to C, means automatically you can conclude that fourth job can be allocated to D. Okay, since compare these two, which is having least cost 13. Okay, now this 13 acts as the upper bound value. So here now this 13 acts as upper bound value. So already you fixed lower bound value as 8, and this 13, the final 13 can act as a upper bound value. Okay. See here, so the minimal cost is nothing but upper bound value minus lower bound. The upper bound value is taken from the leaf node, from the, it's not leaf node, the level before the leaf node. The level which is available before the leaf node, you can select the upper bound cost. So this upper bound cost is nothing but 13 minus lower bound cost is nothing but which can be taken from the root node. This is leaf level minus 1. This 13 is taken from the leaf level minus 1 and 18 is the root node. So the minimal cost is equal to 15. So this will be one answer. And the next answer is job assignment is job 1 be allocated to person B, 2 will be allocated to person A, 3 will be allocated to person D, and 4 will be allocated to person D. So this is taken from the state space tree. Is it clear? So this is taken from the state space tree. See here. So from the state space tree, you have to write the answer. First job is second person, second job is to allocate it to the first person, like that. You have to write the final answer. Is it clear? So the final answer is two things. You have to write out the minimal cost as well as you have to write out the job assignment task. Is it clear? So this is the corresponding algorithm. You just go through it. You just go through this algorithm. Okay. Students, do you have any doubts up to this point? So I'm waiting for your response. Do you have any doubts in branch and bound algorithms? So we have completed TSP problem, we have completed assignment problem as well as AMSOC problem also. Do you have any doubts? So I'm waiting for your response in the chat box. No, I need at least 5 responses. If 1 or 2 students only responded, means then how I will take it in the right sense. So please enter your response. If you have any doubts, please unmute your mic and clarify your doubts. You are always welcome to ask the questions. So far, we have discussed only how to solve the problem. Okay. In most of the cases, we did not discuss about the algorithms as well as time complexity. If time permits, I will copy and paste it in the PPT and I will share it with you. Or else, you can refer the book. Okay. You can refer the book for the algorithm. Since you know how to solve the problem, isn't it? Then you can write yourself the algorithm, or you can refer materials in net or some other books. Okay. If you know the algorithm, then you must know how to solve it, isn't it? Okay, ma. So we will move to the next one. Okay. So I think we have entered into the last module. That is nothing but limitations of algorithm power. That is NP completeness. Under this, we are going to discuss about these topics: reduction amongst problems, classes NP, P, NP complete, and polynomial time reductions. So we are going to discuss the topics one by one. I think remaining, you just go through the syllabus. Okay. If any topic is left out in previous 7 modules, let me know. Students, so this case study is not discussed in the class. Since the name itself indicates case study, okay, you have to solve it. I think so remaining we have discussed everything. You just go through it, ma. So in the next class, you have to tell whether any topic is left out in the above 7 modules. So far we have discussed 7 modules. Okay, now we are going to enter into the eighth module. That is your CO5, I think. Before that, let's discuss CO5. CO4. See, CO4, this problem you can solve it. Solve the following instance of the knapsack problem by using branch and bound algorithm. Okay, you just apply the concept whatever I have discussed in today's class. Solve n-Queen's problem. This comes under which topic? N-Queen's problem. N-Queen's problem comes under backtracking, isn't it? So N-Queen's problem comes under backtracking. So already we have discussed a 4-Queen's problem, but this is a generic one. So you can write the algorithm in general. Then find the solution for assignment problem using branch and bound technique. Okay. So this will be the branch and bound techniques, but here they have to give the graph. If the graph is not given, it's not graph, the table should be given. If the table is not given, you can assume your own table and you can proceed. Okay. So this is a CO4 and your CO5. Okay, so CO5 is somewhat little bit difficult to understand. Okay, so let's discuss the topics. So I will try to convey the content in the easier manner so that you can easily follow. Okay, I think you can't able to understand what is present as of now. So we will discuss the topics, then we will come back these questions later. And the CO6 is the common. Okay, CO6 is combination of all above modules. So this is like a mini project. You have to combine all above modules. So now we are in CO5. CO6 is combination of all the above modules. Okay. So there is no need to worry about the CO6. Only thing is you have to worry about first 5 COs. First 5 COs. Okay. Okay. See, so if you compare the time, this will be the polynomial time and this will be the exponential time. See here, it is exponentially increasing. So in the sense that that the complexity will be very high. For example, if n is equal to 100, see 2 to the power 100, how much value this will be? If n is equal to 1000, see 2 to the power 1000, how much the value will be? Okay, if it is exponentially increasing means it is the computation time will be very biggest one. Okay, so with respect to this polynomial time and exponential time, we are going to discuss about NPP complete problems. Okay, so polynomial time in the sense that which may be in n